the UDL, uniformly distributed load on every beam, have been arrived. From this, we should arrive the maximum bending moment on the individual beams for the designing the beams. IS code clearly prescribes that in table number 12, IS 456 2000, the bending moment coefficient or the bending moment is 1 by 12 WL square. This is 1 by 16 WL square, or likewise various places it has been sorted. You please see this table if you come across this. For this, dividing by 12 will give a lesser value, dividing by 10 will give a get better value. So we are assuming that 1 by 10 WL square has been taken for the simplification of this calculation. Good. Okay. For this W, for this beam, WL square by, that is 1 by 10 WL square equal to what? W means unit weight. This is small w, this is not capital W. It is 26 point 36 into L equal to 5.1 square by 10 equal to what? 26.36 into 5.1 into 5.1 by 10 equal to 68.56 kilonewton meter. The unit of bending moment is kilonewton meter. As we are calculating this in kilonewton and we are making it into meter, then it is kilonewton meter. Likewise, we calculate all. The cantilever, as far as cantilever beam is concerned, we know very well that this is a fixed support, this is a cantilever. For example, you take it, this is a fixed support, this is cantilever. If you, this is W per 1 meter, the bending moment at this is WL square by 2 is the formula for maximum bending moment at the fixed support. Using that formula, here we have calculated that the total weight per unit is 36.9 into length is 1.03 into 1.03 by 2. This is the bending moment at this point, 19.57 kilonewton meter. Likewise, you calculate all the cantilever beams also. That this bending moments I have already calculated and I have written here. This is 68.56, as we have already done. 68.56 it is here, that I have brought here. This is the cantilever bending moment. We have already calculated as 19.56. This I have brought here as 19.56. Similarly, I have calculated the bending moments on maximum bending moments on all the beams. This is, you please note that bending moment in simply supported beam is taken as WL square by 10 or 1 by 10 into WL square. Cantilever bending moment is WL square by 2. This bending moment is not only midspan bending moment, this is the same as the bending moment at the support. That is, sagging bending moment at the midspan is the same. Hogging bending moment at the support is also the same. That is how we are simplifying this calculation. So we should design for the sagging bending moment also, and also for hogging. Hogging bending moment is the bend of the beam upward. Sagging bending moment is the bend of the beam downward. Okay. Coming to the previous drawing, we say that 26.36 is the kilonewton per 1 meter length of that beam. From this, we are going to calculate the load transferred by the individual beams to the nearest column. Okay. If this is 26.36, what is the load transferred to this column and this column? For this, IS code book IS 456 2000 clearly indicates in its table number 13 that the shear for coefficients, that is, shear means the shear value, shear total force transferred by the beam at the end of column, is calculated in this tabulation. In this, actually, for a simply supported beam, if you take it, this is a simply supported beam. If this is the load, then the shear force at this point will be WL by 2, total load by 2. This is also WL by 2. Total load by 2 is the formula for the end shear force. That is the load transferred to the support. But for a continuous beam, they have given a prescribed tabulation in which it is clearly said that the load transferred to the end support is 0.4. Other places this is 0.6. The next to the end support this is 0.6. Other places they have calculated as this is 0.55. That much this we shall adopt these three only. If we calculate all these things, the calculation will become more complicated, and adopting this will be in the safer side only. So we are taking these three coefficients for calculating the load transferred by the beam to the end column or the shear force on the beam. Okay. What about this? Supposing if we take this beam. If you take this beam, the UDL is 36.09. The end reaction we have already taken it as WL into 0.4. We have already calculated this is 0.4. See here, this is 0.4 for end support due to dead load, imposed load, fixed. This is this is 0.45 if for the live load which is not fixed. It is the live load or which is not fixed in loads are very minimum, and this difference will not be a matter, will not be considerable. So we shall take it as 0.4, which is in the safer side only. So take it as 0.4. This value is 36.09 into length is 3.2 plus 3.2, 6.4. This is WL, sorry, into 0.4 equal to load transfer in this portion is 92.39 kilonewton to this column. As far as this area is concerned, this is 0.6 into WL. What is 0.6? This we have already taken its in the inner side. That is 6.09 into W in W length is 6.4 into zero point 0.6. This is 138.58 kilonewton. This is the load transferred to this column. This is the load transferred to this column. Other place, this is also in end column. For this, that we shall calculate. For this is a cantilever slab which gives, there is no column in this area, so the total load comes to here only. So what is the total load? This is uniformly distributed load is 26.95, length is 1.03. So total load transferred or shear transferred is 27.76 kilonewton. Likewise, you calculate all these things. The calculation of load transferred by the individual beams to the column or the maximum shear force at that, sorry, the calculation of the load transferred the beam to the column or the maximum shear force on the beam I have already calculated and written on this sketch. This, for this beam, in the previous sketch we calculated that this is 92.39, this is 92.39 I have put here. This end moment is 138.58 kilonewton, 138.59 kilonewton I have already written on this drawing. This end reaction, this cantilever, this is 27.96 kilonewton we have calculated in the previous drawing. This is 27.75 kilonewton I have written here. Similarly, I have calculated all the loads I have and I have put in this. For example, if this column is taken, load is given by this beam and this beam and this beam. The values are given here. For the central column, loads are given by 4 beams. So the total of these is the load bared by this column per one floor. So what is the load transferred by these 3 beams to this column is counted by, is calculated by 43.79 plus 92.39 plus this value 43.79. Load on this column is 179.97 kilonewton per one floor. This is also, this is a one floor load. Likewise, I have calculated all the loads transferred by the beam to the column in every floor, in each floor. This we have already calculated. This is as this column load is 179.97 kilonewton. This I have put here 179.79 kilonewton. These values I have written little inclined to indicate that this is not a load of beam. This is a load on column. So likewise I have written on these things. These are the loads transferred by the beam to the column per one floor. This is for one floor only, axial load. Dear viewers, if this video is interesting to you, please give a like to this, subscribe this video and forward this video to your engineer friends, architects, students. We will see the method of calculation of loads in column from all the floors and including sulfite, which is the most important point for the construction in the next video. Thank you.